Determine the domain and range of a rational function. Okay, here we have a rational function, and we're asked to determine the domain and range of this particular rational function. Again, it is a rational function because essentially it's a polynomial or a function over another polynomial. So it's essentially a function over a function. First, to determine the domain, what we're asked to find out when we're asked to determine the domain is we need to find out where it exists. As we know, every polynomial exists everywhere, so the domains are all real numbers. However, that's not true when we have a rational function, because we are not allowed to divide by zero. We're not allowed to have zero in the denominator. Therefore, essentially, the easiest way to find out the domain is we want to find out where this function does not exist. And in order to do that, essentially, is we need to find out where we end up with an undefined or a zero in the denominator. So to do that, we take the bottom function, which is x squared minus 4, and we set it equal to 0, and we solve. So solving out, factoring out, obviously, x minus 2 and x plus 2, we end up with the fact that in this solving for the x, we have x, in this case, equals negative 2 or 2. Essentially, though, what it's really saying is that's where it equals 0, and as we know for the rational function, that's where this function cannot have those values because they take on the value of 0, which gives us a 0 in the denominator. So for this particular rational function, setting the denominator function equal to 0, we have the domain equal to all real numbers, with the exception that x cannot equal negative 2 and 2. And in interval notation, that would take on the form of, for interval notation, that takes on the form as basically we always start from the left as negative infinity to negative 2, rounded parentheses, union, because it does exist in between the 2's, 2 and 2, again rounded because it does not include that value, and then from 2 to infinity. So that's how it would be in interval notation. Now, for the range is a little tougher. You can't just automatically look at the function and determine it. The best way to determine the range of this particular function is by graphing. So to graph this, we take a look, we're going to plug it into our calculator. So I plug this into my graphing calculator, the function x squared minus 5x over x squared minus 4, and when I go to graph this particular equation, I end up with a graph that looks something like this. Obviously we have essentially negative 2 and positive 2. We can see that it doesn't exist there because that's basically where we end up with 0 denominator, but we do have a value in between the two. So the range, remember, is essentially my y values, my old up and down. So you can see if I zoom out, continue to zoom out, this goes on all the way to negative infinity, and this goes all the way up to positive infinity. So my range in this particular case is going to be negative infinity to positive infinity. And the way that looks in interval notation is this. Again, my range is basically, in interval notation, is negative infinity to positive infinity. And infinities are always around in parentheses, or you can simply say all real numbers.